Okay, this is going to be the video lesson for Unit 5 for pre-calculus. This is going to be log and exponential graphs. I want to start out with an exponential graph here. Okay, let's say I have y equals 3 to the x minus 7. Okay, now just like our normal graphs, we want to find anchor points first. So what we treat is this is like the inside of the function. Okay, so my anchor point here would be 2, -7. Opposite, follow. So 2 over 1, 2, 3, 4, 5, 6, and then let's do another line here, 7. Okay? All right? Now, what we want to do, that's our anchor point. Now, if you have an exponential, okay, you have a horizontal asymptote. If you have a log or natural log, you have a vertical asymptote through the anchor point. Through the anchor, okay? So it's a little bit different, all right? So here, boom, I have this anchor point here, all right? Now, what I want to do, okay, I want to make my chart. Now, in the past, we've used the points 1, 2, -1, -2. I'm also going to use the point of 0 for exponentials and logs, okay? So the idea is I would do 3 to the x power. Now, from a calculator standpoint, 3 to the 0 is 1, okay? 3 to the first is 3. 3 to the second, okay, is 9. You should be able to do this without a calculator. Now, the concept of 3 to the -1, what that's going to be, it's going to be 1/3. So it like flips this. That's what's a little bit different. So 3 to the -1 is 1/3. 3 to the -2, okay, now that's going to be 1/9, okay, all right, because remember, negative exponents flip that, okay? So what I would do, just like I've done with all my graphings, and I graph this from the anchor point. So 0 over 1 up, 1 over 1, 2, 3 up, 2 over 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 left, a 1/3 down, 2 left, all right, right about there, okay? And so then I draw this, boom, through here, okay? All right, now, what I want to do to find the domain and range is label the arrows. This arrow is easy. That's going to be a right arrow going up. What you have to watch out for with your arrows is what asymptote does it approach, okay? So this line here would be the y equals -7 dash line. So when I label that, all right, if I got y as -7, then this arrow would be -7 for the y and -infinity for the x. So you got to be careful about that. So the domain, smallest x to biggest x, -infinity to positive, okay? All right, my range, smallest y is -7. Since it approaches the asymptote, I do a curved bracket. My biggest one is infinity, okay? Increasing, decreasing, the same. Start from here. Boom, that's an increase the whole way from -infinity to infinity. This would be none, okay? Your x-intercept you can estimate. So that's 1, 2, 3, I don't know, like 4.7. I'm not going to be overly picky with that, all right? And then my y-intercept would be like right here, which would be like almost 7. Let's say 6.8. Y equals -6.8. So just use your estimates. So you want to estimate these, okay, on these graphs. That's what we're going to do this year as far as finding those things, okay? Let me do another example of an exponential. Oh, whoops, I put that on the first page, didn't I? All right, let me go back to here. Whoops. Okay, let's do this one. Let's do this one here. Y equals 2. Let's put a negative out front. X, let's say plus 5. Okay? All right. 2 to the negative x plus 5. All right, so got to be careful with our anchor point here. There's nothing inside for x, so that would be a 0. The opposite out here would be a 5, so 0 over 1, 2, 3, 4, and 5. Okay, I've got a horizontal asymptote, so that would be through the equation y equals 5. Okay, then what I want to do, I'm doing 2 to the x, so 0, 1, 2, negative 1, negative 2. 2 to the 0 power would be 1. Okay, 2 to the first power is 2. 2 to the second is 4. Or 2 to the negative 1 is 1/2, and that's what we should expect from that. This will be 1/4. Okay, 2 to the negative 2, 1/4. Okay, now this negative out front, I'm going to multiply all the y values by negative 1. So that's going to be negative 1, negative 2, negative 4, negative 1/2, negative 1/4. Okay, so from my anchor point, 0, negative 1. Okay, 1, 1, 2, and then 2, negative 4. 1, 2, 3, and 4. Okay, from my anchor point, 1 left, a 1/2 down, 2 left, a 1/4 down. So this is what it looks like. It's not a very good drawing. Okay, now let's label our arrows. This is my right arrow going down, so positive infinity, negative infinity. This approaches the line y equals 5, so that would be 5, and this would be my negative x value, okay, for that. So my domain, smallest x is negative infinity, biggest is positive, okay? My range, my smallest y value, be very careful, is negative infinity. My biggest y value happens to be 5, curved bracket, okay? All right, increasing or decreasing, start from the left. Now this is decreasing the whole way, okay, none. All right, my x-intercept, I would estimate that at like 2.1. My y-intercept was really easy, 1, 2, 3, 4, that's at negative 4. I'm sorry, positive 4, okay? And that's how we get our answer for that, okay? Now, with logs, okay, now that we've done that, let's talk about log graphs, okay? Let's talk about log graphs. So I got y equals log base 3, x plus 5 minus 1, okay? Now, my anchor points are done the same. They're actually easier. Negative 5, negative 1. So 1, 2, 3, 4, 5, negative 1. Now, I would have a vertical asymptote. So that's going to be at x equals negative 5. So that involves your anchor point. Okay, that's how you know. X, Y, all right? Now, there is no easy fix here for this. What you have to do is you have to look at the base of the log, okay? So the base of my log is 3. So what I'm actually going to do is I am going to make a chart based off of the concept of 3, and we'll talk about more about inverses. Logs and exponentials are inverses of each other, okay? So if I do 3 to the 0 would be 1, 3 to the 1 would be 3, 3 to the second would be 9. This would end up being 1/3 and 1/9. Now, to make the log graph, what you do is switch x and y, all right? So what I would have now is 1, 0, 3, 1, 9, 2, 1/3 negative 1, 1/9 negative 2, okay? And if there's ever anything to apply, which we'll talk about in the next example, always do if there's like a number out front, do that second, okay? Do that second. So let's go through this. 1, 0. So 1 over 0 up, 3 over 1, 2, 3, 1 up, 9 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Okay, 1/3 over 1 down, 1/9 over negative 2 down. So, well, yeah, sorry. All right, so this is what it looks like now. right? Now, this would be positive infinity, positive. Okay, now, gotta be careful here. What is this equation? Y equals negative 5. So that's negative 5 for the x coordinate. What is the y coordinate doing? It's going down, so it's negative infinity. Okay, so for my domain, my smallest x is negative 5. My biggest is infinity. For my range, my smallest is negative infinity. The biggest is positive. This is increasing the whole way from negative 5 to infinity, so there is no decrease. My x-intercept, that's easy here. That's actually at a point of negative 2. My y-intercept, I'm going to estimate that at 0.5. Okay, as long as it's reasonable, you're good. Okay, let's do another example of logs. Okay, let's do another example of logs. Let's say I got y equals negative log 2 x minus 3 plus 4. Okay, all right, so I want to do my anchor point, 3, 4. Okay, so 3 over, 1, 2, 3, 4 up. Boom, I know that's that, because that's x, that's y. My asymptote would be x equals 3. Now, what I want to do is, since I have a base of 2, I want to work from the exponential of 2. 2 to the 0 would be 1, 2 to the first 2, 2 squared 4, 2 to the negative 1, 1/2, 2 to the negative 2, 1/4. Okay? Now, I see I have a negative out here. I want to wait to apply that until I flip the chart. Okay? So my actual chart for my log base 2 would be 1, 0, 2, 1, 4, 2, negative 1/2, not negative 1/2, positive 1/2. 1/2 negative 1. Okay, 1/4 negative 2. I didn't do that in the last one, did I? Did I make that as negative? No, good. All right. Whew. All right, so 1/4. All right. So now what I want to do, since I've got this negative out here, I want to multiply all of these by negative 1. So that would still be 0. Now that would be negative 1, that would be negative 2, that would be positive 1, and that would be positive 2. Okay? So from my anchor point, 1, 0, so 1 over 0 up, 2 over, negative 1 down, okay? 4 over, 1, 2, 3, 4, 2 down, okay? 1/2 over, 1 up, 1/4 over, okay? I'm sorry, 1/2 over, 1 up, 1/4, 2 up. So here's what this looks like. All right, so this arrow would be a right arrow heading down. This one, all right, this is approaching the line x equals 3. So I would have 3, and that arrow is pointing up, so infinity, okay? All right, so my smallest x value is 3. Okay, the biggest is infinity. My range, my smallest y value is negative infinity. Biggest is positive. Now here, this is a decrease the whole way from 3 to infinity. There is no increase. Now, in the interest of the x-intercept, I really can't see it. All right, can't determine, okay, by the graph. All right, you probably could if you graphed it out further. The y-intercept, there's no possibility, okay, for the y-intercept. Very important thing is, if you have this 4 logs, wait till you flip the chart. Okay, that's really important, okay? All right, so what I would like you guys to do, okay, is go ahead and do these problems, okay? Okay, go ahead and work, pause your video, and go ahead and work on those. Okay, go ahead and unpause your video. I'm going to go through these one at a time. Okay, so I got y equals 3 to the x plus 2, okay, minus 4. All right, so my anchor point would be negative 2, negative 4. Okay, so negative 2, 1, 2, 3, and 4, boom. All right, since it's a horizontal, it would be a y equals based. So that asymptote is y equals -4. I can do that real easy. Okay? I'm doing 3 to the x power, 0, 1, 2, -1, -2. 3 to the 0 is 1. 3 to the first is 3. 9, 1/3, 1/9. Okay? Just flip those over. All right? All right, so from here, from my anchor point 0, 1, okay, from this 1 over 1, 2, 3 up, then 2 over 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1 over, -1 over a third down, 2 over a ninth down. Okay. 2 over, 1 over 1/3, 2 over that. Okay, boom. All right, label my arrows. This one approaches -4, so my y coordinate is -4. That's -infinity. This is positive and a positive. So my domain, negative to positive infinity. My range, that'd be -4 to infinity. It is increasing the whole way. It is not decreasing at all. My x-intercept, let's say -0.8. Close enough on that. My y-intercept clearly touches at 1, 2, 3, 4, 5. Y equals 5. Okay? All right, let's do the next one. Okay. Whoops. All right, let's do y equals log of 2, x plus 5 minus 3. Okay, that anchor point's at -5, -3. 1, 2, 3, 4, 5, 1, 2, and 3. Boom. Okay, this is an x equals, so x equals -5. Okay, all right, now, since I have a base of 2, I want to use the exponential of 2 to help me come up with the problem. 2 to the 0 is 1, 2, 4, 1/2, 1/4. Okay, since it's a log, now I want to flip this over. Okay, so 1, 0, 2, 1, 4, 2, 1/2, -1, 1/4, -2. Okay, nothing out front, so I'm good. So from this anchor point, 1 over 0 up, 2 over, from the anchor 1, 2, 1 up like that. All right, from the anchor 1, 2, 3, 4, 1, 2. Okay, from the anchor point, 1/2, -1, from the anchor point, 1/4, -2. So this is what this looks like. Okay, all right, so label the arrows. This is clearly positive, positive. Since this approaches -5 from the x, it's -5, -infinity. My domain is -5 to infinity. My range is -infinity to infinity. It is increasing the whole way. It's not decreasing at all. My x-intercept, I'll estimate that at 2, and I'll estimate that at -1. Okay? All right? All right, the last one here. My anchor would be -1, 0. All right, that's at x equals -1. Got that out of the way. What do I have? Base 3. All right, so what I want to do, because this is a base 3, 3 to the 0 is 1. That would be 3, 9, 1/3, 1/9. Okay? Even though I have the negative, I'm going to wait to address that until I flip it. Okay? So 1, 0, 3, 1, 9, 2, 1/3, -1, 1/9, -2. So I'm going to take these and multiply by -1. So I got 0, -1, -2, 1, 2. Okay? So from here, 1 over 0 up. Okay? 3 over 1, 2, 3, 1 down. All right, 9 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 down. From here, 1/3, 1 up, 1/9, 2 up. So this is what it looks like. All right, this is going to be a positive infinity going down. Okay, all right, this would be approaching -1 and up from the x. All right, that's what I have. My domain -1 to infinity. My range, -infinity to infinity. I'm increasing, what's happening here? I'm decreasing the whole way from -1 to infinity, and I'm not increasing at all. All right? My x-intercept is easy, it's at 0, and it's the same as the y-intercept. Okay? All right, let's move on to the last thing I would like to talk about today. All right? Let's do, I want to talk about the x plus 2 minus 6, okay? Now, this is just the base exponential, all right? This is the base exponential. It is handled the same way. -2, -6, 1, 2, 3, 4, 5, and 6. All right, so it would be here, boom, whoops, I don't know, 0. All right, this would be a y equals -6 for the asymptote, okay? Still 0, 1, 2, -1, -2, okay? All right, so if you want to fill that in, the e is located right here at the natural log, so shift e, e to the 0 is 1, e to the 1 is 2.7, okay? E to the second is 7.3 or 7.4, we'll just go ahead and round that up. Okay, e to the -1 is 0.36, and e to the -2 is 0.13. Okay, so everything's graphed the same. 0 over 1 up, 1 over 1, 2 and a bit up. 2 over 1, 2, that would be 1, 2, 3, 4, 5, 6, 7, and a little bit. Okay, -1 over 0.36 up, -2 over, boom, so it's the same thing. Okay, all right, just like that. I label the arrows the same. That y is a -6. That's going to be a -infinity. It's going to be positive, positive. Okay, all right, my domain, done exactly the same, -infinity to infinity, okay? All right, my range is -6 to infinity. This is increasing the whole way, okay? So it's decreasing none. I'm gonna estimate my x-intercept at like -0.1. My y-intercept is like 1.5. Okay, it's good enough for there. Okay, now let's talk about how you do that with something called the natural log. Okay, this is called the natural log. Okay, its inverse is with the e to the x. Okay, so when you see this, okay, my anchor point is still -7, -4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, and 4, okay? So that'd be the line x equals -7. No changes there, okay? Now, so there is no base, so I gotta pretend that this is the E one, okay? So I gotta pretend it's E. So e to the first 1, 2.7, 7.4 like we just discussed, 0.36, and 0.13, okay? So when I go over to natural log, I just flip these around. 1, 0, 2.71, 7.42, 0.36, -1, and then 0.13, -2. Same rules. If you have a negative out front, it would now get multiplied by the y's. Okay? So what I would have here, all right, from here, 1 over 0 up, okay? 2.7, 1, 2.7, 1 up, 7.4, 1, 2, 3, 4, 5, 6, 7, and a bit, 1, 2, okay? And then these other ones, 0.36, -1, okay, 0.13 here. Actually, I'm sorry, this should be 7.4. This should definitely be here. Let's go 1, 2, 3, 4, 5, 6, 7. Should be 7 here. Okay, and then up 2. Okay. Wait, hold on. Let me fix this points. 2, I forgot my chart here, how it goes at. 1, 2, 3, 4, 5, 6, 7. Okay. All right, let me fix the chart. All right, so this is 6. So 1 over 0 up. 2.7 over 1 up. 7.4. 1, 2, 3, 4, 5, 6, 7 and a little bit. There we go. Then 0.36 over, 1 down. Yep, and now this is what I have. All right, this would be infinity, infinity. Okay, this would be at -7, negative infinity. Okay, same rules as before. So this is -7 to infinity. All right, my range is negative infinity to infinity. Okay, it is increasing the whole way from -7 to infinity, so there's no decrease. That's crossing at 1, 2, that's at like -2. We'll just y-intercept of -2. The x-intercept we can't determine. Okay, all right. So I would like you guys, okay, to go ahead and try these questions. Okay, go ahead and try those. Pause your video, and then I'll go over them. Okay, go ahead and unpause. I'll start with this one. That would be 1, -4 here. So that's going to be y equals -4. Okay. Since we're dealing with E, okay, all right, that's what I would have. So 0, 1 from here, 1 over 2.7 up, 2 over 1, 2, 1, 2, 3, 4, 5, 6, 7 and a bit. Okay, 1 left, 0.36 up, 2 left here. Okay, infinity, infinity. This would be negative infinity, -4, because that's the y coordinate. Okay, domain is negative infinity to infinity. Range is -4 to infinity. It's an increasing the whole way. That's a none. Okay, my x-intercept 1, 2. We'll say 2.5, and my y-intercept 1, 2, 3. Like -3 point. Let's say 3.6. Okay. Let's go to the natural log one. Okay, so my anchor point would be -5, -1. Boom. Okay. So I would go e to the x, 1, 2.7, 7.4, 0.36, 0.13. Since it is natural log, I am flipping that. Okay, so from here, 1, 0, 1, 2, and a bit, plus 1, 1, 2, 3, 4, 5, 6, 7, and a bit, plus 2, right? 0.36, -1, 0.13, -2. Okay, so since my asymptote here would be at -5, it's -5, negative infinity. This is positive, positive. Domain is -5 to infinity. Range is negative infinity to infinity, increasing the whole way. My x-intercept, I'll estimate that at like -1.5, and my y-intercept at 0.5. Okay, so I know that's a long video. All right, we'll see how far we can get in class with that. There are some, like I said, a lot of details here, so we'll play it by ear.